In this session, I would like to talk about ALU and data path. So far, we assume that whenever we have instructions, they are automatically getting executed, correct? But that is not true. Someone should execute them, correct? Now, how that execution takes place, we are going to study now. So that is a topic called ALU and data path. First, we study that. After that, we will see a concept called pipelining. Pipelining is also very important topic for us. So in pipelining, what are we going to study is how to execute the instructions parallelly. Before that, you should know how a typical instruction is going to be executed. For that, what is the machinery we have, how to arrange that machinery, that we will study in this ALU and data path. Okay, so after that we will see how this pipelining effectively work and how effectively that pipelining is helping us in executing the instructions parallelly. We will see that later. First of all, you should know how to execute an instruction, what are the various phases we have, everything. Okay, let us begin with typical steps in instruction execution. So you might think that whenever instruction is getting executed, so this idea, right? So first of all, we have to fetch that instruction. Yes, after that we have to execute. Absolutely right. First of all, we have to fetch it, after that execute. So if I extend that idea, whatever you told, fetch and execute, then I can understand the same idea with three steps. You see, typical steps in instruction execution is, first of all, fetch the contents, correct? So I assume that, let's say your instructions are already loaded in main memory. Okay, let me store them here: I1, I2, I3, I4. Okay, now initial starting address is 100. Now there is a register called program counter. That program counter is already stored with 100. Let's say that is the assumption. Your assembler, otherwise loader, sorry, not assembler. So loader, once you have a machine instruction program, then the loader can do this thing. That means your program can be loaded somewhere in the memory and the starting address can be kept in program counter. Such a way loader will work, and after that your program starts executing. Okay, now I'm talking about this idea. When you have already your program in your memory and program counter already showing the starting address, that will be done by loader. Now we will not worry about that loader part. We will see now the remaining part. Once you have this configuration, what are the things are going to happen, we will see. The first thing is, fetch the contents of the memory location pointed by program counter. Correct. That means program counter points some instruction, fetch it. So fetching is nothing but you have another register called instruction register. Remember it. Okay, so your machinery should be designed such a way that that instruction which is pointed by this program counter should be transferred to instruction register. Okay, then I1 will come. So that is nothing but a memory operation. Okay, we can design, not a big deal. Okay, so it is just transferring the data from 100 to this instruction register. So that is what the first step I can say. Now using register transfer logic, so otherwise in high level, symbolically I can show like this. The content of IR should become what? You see, content of program counter, we have to go take the content of program counter. This content of program counter is 100, correct? Then content of 100, that means value at 100. What is value of 100? I1. So I1 should be fetched into instruction register. So that is the first step. Now one more thing. The students who are watching my lecture, if you want to understand pipelining very clearly, first you should understand how your instructions are going to be executed. Then only we can clearly understand pipelining. That's why we will go very slow first. Second step is increment the program counter to point the next instruction. That's obvious, right? Once we execute this instruction, what are we going to do? We are going to execute the next instruction, most probably, unless it is a branch instruction. I'm talking about regular thing. Okay, now if it is a straight line program, that means instruction execution is in a straight line sequencing, then what is going to happen after this step? Program counter will be incremented by 4 units, because I am assuming that every instruction consumes 4 bytes. Okay, that is one thing. Every instruction consumes 4 bytes. Second thing, I am assuming this machine is byte addressable, so that the next instruction's address will be 104. That's why PC equal to PC plus 4. So here this suffix, if I write like this in the braces, like the meaning of that is content of PC. Content of PC is what? 100. 100 plus 4, 104. 104 will be stored in PC. That is the meaning of this one. You can easily understand. What is the third step? Carry out the operation which is, specified by the instruction in instruction register. That's it. Already we faced the instruction, right? That is where in the instruction register you execute it. But still you did not teach us how that instruction will be executed. I will explain that part. But if you see in the broad way, there will be three things, correct? Fetch the instruction, increment the program counter. Third step is carry out the operation. This is general thing, right? Unless there is a branching everything. We will see that things later. So this is a rough idea. Now, sir, what is the meaning of execution generally? So whenever I say we are executing the instruction, most probably in RISC instructions, we will be doing these things. I will tell you. Example, let's say one typical instruction is load, correct? Focus on these three instructions first. Load, add, store. Okay. In load, what are you going to do? If really, let me write load first. Load into register R1 something memory of 1000. Okay. Something memory locations 1000. Okay. That means what? The value at memory of 1000 we are storing in R1. Correct. So second thing, let's write like this: add R1, R2, R3. That means what? How to execute this one? Really, if it is executed, what is going to happen? R2, R3 will be added and that result will be stored in R1. Remember it. Similarly, store can be understood like this. Store R1, we will be writing something memory of 1000. This time, we will be storing some data which is now in R1 into memory of 1000. Of course, you know that, right? So, in these three instructions, if you observe, the one thing you are doing is you are accessing the memory, correct? In this instruction, you are accessing the memory and getting some data and we are storing into R1, correct? That means transferring the data to R1. Second thing here, you are adding the values which are stored in R2 and R3. That is what you are doing here. Now after that you are storing the result into R1. Now what are you doing here in store? We are storing the value which is specified in R1 into a memory location 1000, correct? For that we are going to memory and we will be storing the result. So if you understand these steps, then you can understand this one. What is that? The major steps in execution of any instruction, typically this thing. You will be doing these four operations. See, the major steps we perform generally is reading the contents of a given memory location, correct? You see, example, if I write, the meaning of this one is load R1, let's say memory of 1000. To execute, whenever you are executing this instruction, what are you going to do? We are going to, take the value from the memory location 1000 and we are transferring into R1, of course. For that, we are reading the contents of a given memory location, correct? Maybe you are doing that. I am not saying that always you do that. It depends on the instruction. Otherwise, you will be doing, reading the data from one or more processor registers. Example, let's say you are doing addition. Add R1, R2, R3. Then what are you going to do here in this one? Execution means read the value in R2, read the value in R3 first, after that do the addition, correct? So maybe you are reading one of the typical operation you will be performing in add R1, R2, R3 is reading the values in the register R2, register R3, correct? So that is one typical operation you will be doing, correct? Without that, can you do that? No. So that's why. Third thing, perform the arithmetic or logic operations. In this one you can see. After reading, example, you see this one, add R1, R2, R3. Whenever you have this kind of instruction, what might happen is, so your register R2, register R3, that data will be first of all read somewhere, okay? So we read this value. Mr. Read R2, please give your value to me. Mr. R3, I am taking your value into some temporary register temp1, temp2, let's say. That means what? We are reading the data in R2 and R3. After that, we will be connecting them to maybe adder, correct? Adder circuit. If this happens, then what are we doing here? To do addition of R1, R2, R3, we are reading the data from R2 and R3. Then we will be adding them later, correct? So that's why I can say that. So typically, the typical instructions typical operations we use in execution of any instruction, maybe reading the contents of the memory location or reading the data from one or more processor registers, otherwise performing the arithmetic, Arithmetic includes addition, subtractions, multiplication, division, maybe left shift, right shift, everything. Otherwise, you will be busy storing the data into memory locations or registers, correct? Store data from processor register to a given memory location. Maybe you are storing the data from processor register to given memory location. These are the typical operations we are going to do whenever we execute an instruction. That is about instruction execution. Now we will see more details. See, slowly we started understanding what is instruction, correct? After that we understand typical steps in instruction execution. After that we realize that what are the, execution of instruction means what are you doing? Maybe you are adding, maybe you are reading the registers, otherwise you are reading the memory location, otherwise you are storing some value into memory, right? These are the typical operations we perform, especially in RISC kind of instruction set, correct? Now we will see more details.